Dear students, today I would like to discuss about nernst equation, which is very important concept in electrochemistry. So nernst equation, which is used to calculate the electrode potentials with other than unit concentration of ions in solution. So which is obtained from the thermodynamic relation, that is the relation between Gibbs free energy function and also standard Gibbs free energy function and also EMF of the cell. That is nothing but delta G is equal to minus NF E. Delta G is equal to minus NF E cell. This is change in Gibbs free energy function and the relation between change in Gibbs free energy function and EMF of the cell. So delta G naught standard Gibbs free energy function is minus NF E naught cell. This is standard Gibbs free energy function. So according to thermodynamic equation, the relation between delta G and delta G naught is delta G is equal to delta G naught plus RT into RT ln Q. Substitute delta G and delta G naught values in this expression. Delta G is equal to minus NF E cell. Delta G naught is equal to minus NF E naught cell plus RT into ln Q. So divided by NF and minus is common in both sides. So we get minus NF E cell is equal to minus of NF E naught cell minus RT ln Q. Common minus. Minus and minus are cancelled with each other, and the throughout equation is divided by NF. Then we get E cell is equal to E naught cell minus RT into ln Q. E cell is equal to E naught cell RT by NF into ln Q. So here natural logarithm is there. To convert natural logarithm to the base term, you have to divide. We have to multiply with 2.303. Then the reaction is converted into 2.303 RT by NF into logarithm of Q. Substitute R is equal to 8.314, T is equal to 298, F is equal to 96,500 coulombs. Then we get E cell is equal to, E cell is equal to E naught cell minus 0.059 by n into log. This is a nernst equation. So a nernst equation for metallic, how can we calculate the EMF of the metallic electrode and also EMF of the anion electrode or cation electrodes? So for cation electrodes, nernst equation is E cell is equal to E naught cell. E cell is equal to E naught cell plus 0.059 by n into logarithm of metal ion concentration. This is for cation electrode or metallic electrode. For anion electrode, for anion electrodes, E cell chemistry equation is E cell is equal to E naught cell minus 0.059 by n into logarithm of non-metal ion solution concentration, A n minus n concentration. So by using these two equations, that is for cation electrode or for metallic electrode, we can calculate the EMF value. E cell is equal to E naught cell plus 0.059 by n logarithm of Mn plus n concentration. For anion electrode, E cell is equal to E naught cell minus 0.059 by n logarithm of An minus n concentration. An minus n concentration is nothing but concentration of anion. Next, how can we calculate the current efficiency? So current efficiency, CURENT, current efficiency. Percentage of current efficiency. Percentage of current efficiency. Percentage of current efficiency is equal to actual mass produced by or actual mass of substance. Actual mass of substance divided by expected mass of substance. Actual mass of substance divided by expected mass of substance. Expected mass of substance into 100. By using this formula, we can calculate the efficiency, percentage of current efficiency. And one more is there, that is the relation between equilibrium constant and free energy. This is most important. The relation between equilibrium constant and gives the free energy, delta C. And first we have to know what is the relation between Kc and delta G. According to thermodynamics, delta G is equal to minus 2.303 into minus 2.303 into RT into log Kc or log K. Log Kc or log K. So how V naught value or EMF value of this cell and also equilibrium constant are related with each other. So according to thermodynamic equation, delta G naught is equal to minus n of E naught cell. Delta G naught is equal to delta G naught is equal to 2.303 RT into log K. So substitute delta G is equal to minus N of E naught cell in this expression. We get minus N of E naught cell is equal to minus 2.303 RT log K. Therefore, E naught cell is equal to minus 2.303 by NF into RT log K. Or minus cancel, but minus and minus cancel it. E naught cell is equal to 0.059 by N into RT into 0.059 by N 0.059 by N LMK. This is the relation between E naught cell and 0.059 diameter log K. Okay. One more relation is there. That is if the cell contains two half cells and two half cells in which the concentration of ions are different. For example, Zn bar Zn2 plus, which has concentration C1, salt bridge, Zn2 plus C2 bar Zn. Two half cells are similar half cells, but the concentration of ions in the solution are different, and the concentration C2 is greater than C1. If the concentration C2 is greater than C1, then we can calculate the EMF of the cell like this. E cell is equal to 0.059 divided by N into logarithm of C2 by C1. But in the case of gaseous electrodes, for example, hydrogen electrode, PT, hydrogen gas, the pressure of hydrogen gas is P1 atmospheres, H plus 1 aqueous, salt bridge, H plus 1 aqueous, hydrogen gas, pressure at P2. If P1 is greater than P2, now how can we calculate the EMF of the cell? E cell is equal to 0.059 by N into logarithm of P1 by P2, the most important terms. For hydrogen electrode, pH is given. What is the oxidation potential and what is the reduction potential of hydrogen? So for hydrogen electrode, if a pH is given, then the reduction potential of hydrogen electrode is calculated by using 0.059 minus 0.059 into pH. Oxidation potential of the hydrogen is calculated by using 0.059 into pH. This is most important formula. The numericals are the objectives are given by on the basis of this formula. So you can follow. The reduction potential of hydrogen can be calculated if the pH of the hydrogen electrode is given. Then ERP is equal to EMF reduction potential of the electrode is equal to minus 0.059 into pH. If we ask oxidation potential, then the oxidation potential of the hydrogen can be calculated if pH is given by using oxidation potential is equal to plus 0.059 into pH. Okay, students, based on Nernst equation, how can we solve this problem? The standard reduction potential for Cu2 plus for Cu is plus 0.34 volts. Calculate the reduction potential at pH is equal to 40. For the above couple, Ksp of Cu twice is 1.0 into 10 to the power of minus 90. So first we have to calculate the OH minus ion concentration solution. In the problem, pH is equal to 14 is given. That means H plus ion concentration is equal to 10 to the power of minus 14. But according to ionic product of water, H plus ion concentration into OH minus ion concentration product at 25 degrees centigrade. Kw value is 1 into 10 to the power of minus 14. H plus ion concentration is 10 to the power of minus 14 into OH minus ion concentration. That is, OH minus ion concentration is 1. 10 power minus 14 to 10 power minus 14. OH minus ion concentration is equal to 1. The Ksp value of copper hydroxide, Ksp of CuOH twice is, which is nothing but the concentration of Cu2 plus ion and concentration of OH minus ion square. So Cu2 plus ion concentration is Cu2 plus ion concentration is equal to Ksp by concentration of OH minus square. Therefore, Cu2 plus ion concentration is equal to 1 into 10 to the power of minus 90. According to Nernst equation, E cell is equal to E naught cell plus 0.06 divided by 10 into logarithm of Cu2 plus ion concentration. E cell is equal to E naught cell is given as 0.34. So Cu2 plus 2 Cu. There are number of electrons in over 2. Logarithm of Cu2 plus ion concentration is 10 to the power of minus 19. Since Cu2 plus 2 electrons gives rise to Cu2 plus 2 electrons gives rise to C. The answer is calculation. The answer is minus 0.2. Now one more problem is there for the half cell reaction is E naught is equal to 1.30 volts and pH is equal to 3. Then electrode potential is. This is another model on Nernst equation. So how can we solve the problem? According to Nernst equation, E cell is equal to E naught cell minus 0.06 by n into log Kc equivalent constant. The E cell is equal to E naught cell minus 0.06. 0.06 divided by 2, number of electrons 2 involved in this reaction, into logarithm of H plus ion constant. So E cell is equal to E naught cell is given 1.30 volts minus 0.06 by 2 into 2 into logarithm of H plus ion concentration. pH is equal to minus log H plus. Since pH is equal to minus logarithm of H plus ion concentration to the base 10, then the equation can be written as E cell is equal to 1.30 minus plus 0.06 into pH. pH is given, that is 3, 1.30 plus 0.06 into 3, that is equal to 1.48 volts. This will